Dear student, how are you? I hope you are all will be fine. I'm also fine, thank you. Let's start today topic. Today is lecture number 9 of the Boron family. In previous lecture, I already explained you what is the difference. I already explained you the general characteristic of Boron family, and then I will explain you. The difference between boron and aluminum, the similarity between boron and aluminum. Also, I explained you the difference between boron and silicon. This is the diagonal relationship between boron and silicon, and similarity between boron and silicon. I already explained you. So in today's lecture, from today's lecture we will be discuss all the compounds of boron family. That is the compound of the boron, compound of aluminum, compound of chromium, and so on. So from today we will be discuss. In today's lecture we will be start what is boron, define boron and its occurrence, its extraction, its preparation, also the physical and chemical properties of boron, also the usage of boron and all the compounds of boron. So let's start today's topic. I hope you will be ready. Okay, thank you. Let's start the topic. So start from boron. We will be explain bit by bit boron. First of all, I will be explain you what the occurrence of boron. The occurrence of boron. It is occurrence of boron. So here boron is not found in free nature. Boron, it is not found in free nature, but it will be found in different compounds. It will be found in different compounds. It will be always found in the combined state. Maybe that is in salt form, maybe in the acid form, maybe in the basic form. So I show you some important borons are. The important borons are, that is borax. Borax is very important. Borax, it is the compound of boron. Boron can be combined with the form and form salts, like a borax structure is Na2B4O7 10H2O. This is one borax. It is found in this borax is found in Tibet, California, Kashmir, etc. It is mostly found in Tibet, Ceylon, California, and Kashmir. We will be explain the structure of borax, the reactivity of borax, the preparation of borax later. But first of all, now I'm just showing you that how boron can be combined with another elements. How boron will be exist in combined states. Similarly, Sillimanite also present in sillimanite. Boron is also present in the combined state, like in sillimanite, that is Ca2B6O11.5H2O. This is also, it can be also found in Asia and minor America, also found in America. Similarly, it can be found in the form of pendrinite. For example, Ca2B6O11.3H2O. This is the pendrinite. Also, boron can be found in the form of boracite. Boracite. Like the example of boracite is 2Mg3B8O11O15.MgCl2. This is the boracite. It is found in Germany and Stuttgart. It found in Stuttgart and Germany. Yeah. Also, boron can be found in the form of boronite calcite. Boronate calcite. That is the formula of boronate calcite is CaB4O7 dot NaBO2.8H2O. This is the formula of boronate calcite. The boron can be exist in this form. It is found in child. Similarly, boron can be exist in the kernite form. The formula of kernite is Na2B4O7.4H2O. It is found in Mojave Desert in America. Found in Mojave Desert in America. Yeah. Similarly, boron is also found can be also found in the form of boric acid. That is H3BO3. It occurs in jet steam, also called phenol. It is used in phenol escaping from ground in the volcanic region of Crucible. It can be found in the volcanic eruption. Boron is also found in the form of boride, also called borate. Can be also found in the form of borate. That is like B2H6, B5H9, similarly B5H11. This is in the form of borate, also called boron hydride. So boron can be exist in these all things. These are the occurrence of boron. I hope that will be clear. Also, boron is sometimes also found in the plants. Boron is also sometimes found in plants and sometimes in coal ashes and sometimes in coal ashes. I hope that will be clear. So come to the next point, that is the extraction of boron. How boron can be extracted? That is purely boron. How purely boron can be extracted from these things, from these compounds? That boron can be existed in the combined state. So how boron can be extracted from these combined states? Okay, let's start to points. You can take also screenshot from this point, from this board. Now I am cleaning the board because of to proceed the topic. So come to the next point, that is the extraction of boron. How boron can be extracted from the combined state. Extraction of boron. Okay, let's start. Boron can be extracted from the borax and kyanite. It can be extracted from borax and kyanite ores. But how it can be extracted? How boron can be extracted? It can be extracted in 3 steps. Can be extracted in 3 different steps. That is, first of all, preparation of boric acid. After that, the second step is the conversion of boric acid. boric acid N2, boric anhydride, that is B2O3, that is also called boric anhydride. The next step is the last step, reduction of B2O3, reduction of boric anhydride, or you can say that boron can be extracted from the directly extracted from the boric anhydride, or you can say that to get boron from the boric anhydride. Okay, let's start each step one by one, bit by bit, with detail. Number first, preparation of boric acid. Preparation of boric acid. How? Preparation of boric acid from borax. How boric acid can be found from borax. Before few minutes ago, I explained you that what is the borax formula. I explained you the formula of borax. This is the formula of borax, Na2B4O7. That is called borax. Na2B4O7. That is called acid. When the finely ground borax is heated with concentrated hydrochloric acid, when it is heated with concentrated hydrochloric acid, strongly heated with concentrated hydrochloric acid or concentrated sulfuric acid, when it can be changed into orthoboric acid. It can be changed into orthoboric acid, or called it can be changed into NaCl, 2NaCl plus H2B4O7. That is also called orthoboric acid, and this is the tetraboric acid, because here is 4 boron are used. So tetraboric acid. This is the tetraboric acid. After the tetraboric acid, this tetraboric acid is called, belongs from the boric acid. So boric acid can be prepared from borax. Also boric acid can be prepared from Colemanite, How? The structure of the formula of Colemanite is Ca2B6O11. When the powder mineral of Colemanite is fused with sodium carbonate, that is plus 2Na2CO3, that is sodium carbonate, they will be produced when they are heated. They will be produced 2CaCO3, that is calcium carbonate, plus borax Na2B4O7, that is boric acid. It will produce boric acid. After that, plus 2NaBO2, also that is sodium metaborate. That is also called sodium metaborate. So here is also borate produced. So this is called boric acid, or you can say that tetraboric acid. So here, this is the first step from borax and Colemanite. So boric acid can be extracted, boric acid can be formed. So here from Colemanite, so when we are producing, synthesizing the boric acid, here is the mixture of boric acid and calcium carbonate and sodium metaborate will be produced. But this structure, this is fuse mass. This fuse mass, the sodium metaborate, this fuse mass contains the calcium carbonate. Calcium carbonate, it is in the insoluble form, so it is insoluble in water. So that's why in hot water, when we use this hot water, when we fuse mass is extracted with hot water, the calcium carbonate will be insoluble, so it can be extracted from the solution. So that's why only sodium metaborate and also that is boric acid, these two will be remain tetraboric acid. The filtrate containing borax, that is borax. That is Boric. The filtrated contain Boric and sodium metaborate is put down to crystallization. When Boric is obtained, that is boric acid. When boric is obtained, after that the boric is then converted into sodium metaborate into boric. That will be when they are crystallization. After the crystallization, that will be changed into crystal and it will be separate. After that, this sodium metaborate can be converted also into boric or boric acid. So that's why boric acid can be synthesized through the preparation through this method from the borax and colemanites. Okay, go to the next point, that is conversion of boric acid. Next point is conversion of boric acid into boric anhydride. Boric anhydride formula is B2O3. That is the boric anhydride formula, and structure of B2O3 is like this. That is BO, B double bond O. This is the boric anhydride formula. Anhydride of boron. So this boric acid can be converted into boric anhydride. But how it will be converted? That is H3BO4. So here in this step, before the second step, in first step, that tetraboric acid is also can be simplified. When we add water to this, it will be converted into H3BO3. That is the simplest part. So also this colemanite can also be converted into finally it can also be converted into H3BO3. That is also called orthoboric acid. So here now in this step, this orthoboric acid, or you can say this boric acid, can be converted into conversion of boric acid into boric anhydride. It can be converted into boric anhydride. When boric anhydride, when H3BO3 when orthoboric acid are heated, are strongly heated, it directly convert into boric acid, boric anhydride. That is H3PO4, H3BO3. It can be directly converted into water when they are heated, strongly heated. It can directly convert it into B2O3. This plus 3H2O. This is boric anhydride. After that, this boric anhydride in this third step, that is the reduction process. In the third step, boron can be boron can be synthesized from the boric acid. From boric anhydride, boron can be synthesized. So go to the next point. That is the reduction of boric anhydride. In this step, we will be add boric anhydride to alkali metals. We will be add B2O3 with we will be treat B2O3 with that is sodium, potassium, magnesium, etc. That is alkali metal or alkaline earth metals that are strong reducing agents. So these are strong reducing agents that will be, so that's why they will be reduced boric, and that will be reduce boric acid. Boric anhydride, it will be reduced boric anhydride. So similarly, for example, that is B2O3 plus 6K when they are treated with potassium, it will be produce 2B plus 3K2O. 3K2O. So this is purely boron. This is boron. So boron can be extracted through this way, through this method. Similarly, boron can be extracted when boric anhydride treated with magnesium, or when boric anhydride treated with sodium, it can also be produced. And boron also obtained in this way contain a number of impurities which can be removed by boiling. After that, this contain large number of impurities. It can be pure, it can be boron can be extracted, boron can be separated from this by boiling this mixture. After that, you can add this mixture, you can add HCl, hydrochloric acid, to this mixture. So that's why hydrochloric acid or HF, that is also acid, weak acid, not strong acid like HCl. So you add this, after this the removal of impurity will be occur. But how? So now this mass, this is impure mass, and that is impure boron, because on here is all things are mixed. After that, this will be boiled, this mixture will be boiled, and then add HCl to the solution. After that, HCl to solution, when insoluble boron powder is obtained, after that the reaction of HCl with K2O with potassium oxides, at here boron will be produced. Only boron crystalline boron will be not crystalline, a powder boron will be produced. That is in the form of powder. That is also called amorphous boron. So it will be said in amorphous state. After that, after cleaning this boron, after this cleaning of the boron, it will be the amorphous variety of boron, and amorphous boron are low impurities. That is also called, this boron is also called, because of low impurity, also called Moissan Boron, also called Moissan Boron. Important word, can be used in JEET or NEET like test, and get net test, etc. And the Moissan boron is 95 to 98% pure. It is 95 to 98%. It have 95 to 98% pure boron, and it is black in color. It is black in color. These all are about the extraction of boron. But nowadays boron can be extracted. Boron can be extracted through modern method, that is electrolytic method. I will explain you here now, but now I am cleaning the board to proceed the topic toward electrolytic methods. If you have any confusion in this topic, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in the description box. You can contact me there. Okay, thank you very much. Best of luck. So okay, proceed to the topic. You can take screenshot, or you can rewind the video. Now I'm cleaning the board. Okay, thank you. So modern method of extraction of boron, that is electrolytic method. That electrolytic method. In this method, how boron can be extracted? Boron is obtained these days by electrolysis of fused mixture that contain boric anhydride, magnesium oxide, magnesium fluoride. That is fused mixture. So when you heated this fluoride, this fused mixture, boron can be obtained from a fused mixture of boric anhydride, MgO, that is MgF2, at high temperature. But this process, the electrolytic process, it will be done in carbon crucible. The electrolytic process will be done in carbon crucible. in carbon crucible. What is meant by crucible? What is meant by carbon crucible? Actually, that is very important term. Please concentrate on this word. A crucible is a ceramic metal container in which metal or other substances may be melted or subjected to a high temperature. How can we define? Okay, I am writing here. A crucible mixture. A crucible is a ceramic or metal container. It is like this is container. Let's suppose this is the container called crucible. It is the container. Crucible is the container in which metal or other substances may be melted or subjected to boiling points at very high temperature. Means this crucible cannot be melted. Even the temperature is very high, for up to 1100 degrees centigrade. That is the temperature of when we extract boron to the electrolysis process. So this is the crucible structure. Crucible may be clay graphite. So it may be crucible may be clay graphite, silicon carbide, also steel crucible. These all are crucibles. So at very high temperature, any metals or any compounds, any other substance can be melted in crucible, because the melting point of crucible is very high. It cannot be melted at ordinary temperature up to very high temperature, mostly ordinary high temperature. So when we add this fused mixture that contain boric anhydride, MgO, magnesium oxide and magnesium fluoride to this crucible, this carbon crucible, it may be carbon crucible. At carbon crucible, when we add this mixture to the carbon crucible, the electrolysis is done in this crucible, which act as a anode. This crucible will be act as a anode. That will be act as a anode. Also here in this crucible section, cathode will be used. Cathode will be found from the rod, from the iron rod. It will be iron rod. Cathode will be iron rod. That will be anode. And cathode will be the crucible. Carbon crucible will be cathode, while the anode will be iron rod. This will be iron rod. The magnesium charge at cathode reduces B2O3. Here, due to this crucible, the magnesium will be reduces B2O3. Mg that will be reduces B2O3 and produce MgO plus boron will be produced. Only that is boron will be produced. It is 3 BMgO plus 2 boron, and 3 Mg are added. So here it will be produced boron. Here in this case, in this boron will be purely boron, but it will not be even purely boron. It will be up to 99%. It will be pure boron. Boron thus obtained in heated electrically in regime that 1100 centigrade when all the impurities are volatile. After that, when all the impurities are volatile, the purely boron can be obtained. And also this is the crystalline variety of boron that is obtained from the reduction of B2 from boric anhydride. But this boron will be in the amorphous state. This extracted boron will be in amorphous state. Means it will be in powder state, and purely in hard form, in crystalline form, boron can be produced. But the procedure of to getting crystalline boron, it is different. So the preparation of crystalline boron. preparation of crystalline boron. Crystalline boron can be obtained by reduction of boron anhydride. Boric anhydride, reduction of boric anhydride due to the aluminium or by aluminium, reduction of boric anhydride by aluminium. For example, that is B2O3. They can be, the boron can be, this aluminium can be reduced this boric anhydride and to produce Al2O3 plus 2B. It will be produced 2B. So here in this case, this boron will be pure crystal form. This boron will be crystal form. But now, this is also the mixture. When this mixture are heated with NaOH solution, boron will be in crystal form, so it can be separated from the fire. But in case of this aluminium can be also separated from the solution to reacting this with the sodium hydroxide or the caustic soda. When we add caustic soda to this solution, after the separation of crystalline boron, the impurity of aluminum can be removed, and thus crystalline boron can be produced. This is in the crystalline form of boron. The crystalline boron can also be prepared by dropping amorphous boron in molten state at 1500 degrees centigrade temperature. At 1500 degrees centigrade, when it appears and dissolve and cooling, it produces yellow colored crystal deposit on the surface of aluminium. The mass is broken up and heated with HCl to dissolve away aluminium, and when very hard crystals are left behind, boron obtained by this method is not pure since it contains some aluminium as impurity. But this method, preparation of crystalline, I explained before, by aluminium, it is the best way. I hope these all will be cleared. I think this is enough we should need to end up the topic, end up the class. In next class I will be explain you the properties of the properties of boron and also uses of boron, that is the physical property and chemical property and uses of boron. I hope it will be cleared. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. Okay, thank you very much. Very best of luck, my dear student. Very best of luck. Okay, thank you.